Hello everyone, welcome again to another session from pumpexpert.com. Last two sessions we were dealing about water. Yeah, I know there are some more things which I need to deal with, which is the hot water side of it and the recirculation side of it. But also there's one more, which is the wastewater side of it. What I was thinking is, since we have done two sessions on water, we'll just touch upon wastewater, which is again a very huge subject but a very interesting subject, and I hope I'll be able to give you a lot of information on this wastewater side. What predominantly we are going to do about it in this session today is to discuss about handling sewage. Okay, having said that, first let's start from the very basic, and just the same question which I would like to ask you is, what do you call, which one do you call as wastewater? And the simplest answer that anybody can give you is anything that you cannot drink is a wastewater, which means if you cannot, it's not potable, then it is a wastewater. So except for the drinking water and water which does not have any solids or anything, but if you cannot drink it, it becomes a wastewater. For example, I can tell you seawater also does not have much particle size, but it is a wastewater because of the saltishness it has and the tedious it has. So coming back to all this, when we come into an application area, and wastewater is a very important subject anywhere that you deal with. For example, let's start from a small group of flats where there is a wastewater output and it has to be pumped to the sewer line. Then there is a hotel or a commercial building or an industry which has wastewater. So first we will start with, how do I define the wastewater and what are the criteria I need to know before I select the pump. And also we will be discussing on designing a sewage pumping station or a effluent pumping station, but predominantly I'll be covering sewage, and I'll also be giving you a lot of inputs regarding the others. But first of all, let me classify this wastewater so that my life becomes a little easier. So I'm going to classify it into three categories. One is drainage, effluent and sewage. And how I'm going to differentiate all the three is nothing but with the particle size. Drainage, predominantly for an example from a car park area where there is a small collection pit, that becomes the drainage, and it will have about 15 mm particle size. The next one, if we move to effluent, it's predominantly in the industries, especially if you take textile or leather or automobile, anywhere you take, then you get this effluent. And the particle size for that effluent is about 35 mm. And the third one, sewage, is everywhere, and the minimum particle size that we consider is about 80 millimeters spherical diameter. So based on the particle size is what we classify the wastewater. But why do we need to do this with a particle size? It's very simple. Like, wastewater contains solid matter and we need to pump it, and we need to select the pumps according to the application and the particle size it can handle. So I'll be selecting a pump which can handle about 10 to 15 mm particle size if it is a drainage application. So the first question you ask when it comes to wastewater is, what is the application? I have just tried to simplify it into three. There are so many other wastewaters, but we'll be dealing with that. Predominantly, these are the three things which we come across in our everyday life. So the next one is effluent. And when I come to effluent, I'll be asking them one more question, like, what is the temperature of the effluent? Because that's going to play a major role when you're selecting a pump for effluent, especially when you have tannery effluents. Sometimes you can have a higher temperature, but you should be very careful with it. To give you a ballpark figure, any pump will be able to handle about 40 degrees centigrade. Above that, you need to contact the manufacturer and find out what is the temperature and how you're going to handle it. The third one is sewage, where the particle size is going to be bigger, and the toughest of handling this sewage, the part of this wastewater, is handling sewage. So what we are going to do now is, I'm going to take a small example of a 20-room hotel, 20 to 30 room or whatever. Let's just discuss that. So I'm going to take a hotel which has about 30 rooms, and I'm going to calculate what is my wastewater going to be, how much I'm going to handle, how I'm going to handle, and what is the pipe size I'm going to use. So many things which will be doing it. But let me be very clear with you is that this session may go on for 2 or 3 more videos because there's a lot of information which we need to share. So you need to stay tuned further if you want to follow and know what this wastewater is all about. So without wasting time, I will get into calculating the flow. How do I calculate how much of wastewater flow I need to handle? It's a very simple method that you can use, and most of the people are not aware that just as you calculate your water requirement, you can also calculate your wastewater requirement. So we are going to say that, and again I am going to be using British standards. So I hope it is clear until now. So let's go ahead, and in this video we will be seeing about how to calculate the flow, how I'm going to calculate the head. Once I have both of this, how I'm going to design my pumping station. But design of the pumping station will be in the next video. But anyhow, let's see how we are going to do it. So what I'm going to have here is a hotel which has some floors, and this has 30 rooms. So we are going to calculate how much this hotel is going to generate wastewater and where we are going to collect it. Probably what I'll be having is an underground sump. Like this, and I will be taking the wastewater here, and the sewage is going to come here. So this is my requirement. But I just wanted to explain that I'm going to collect all this sewage or wastewater into this pit, but I need to know how much I'm going to generate from here so that I can design what should be my pit size. So for a moment, just forget this pit. I just drew it only to give you an idea about what we are going to do. So now we are going to calculate. So since it has 30 rooms, the first one what I will take is, it will have a shower. Each room will have a shower. The second one, each one will have a EWC, and the third it will have a wash basin, and the hotel will have kitchen sink, and also the washroom will have a tap point. So since it is 30, I am going to take 30 showers. EWC is going to be 30. Wash basin is going to be 30. Kitchen sink probably is 3. And tap is 30. And again, when you come to water, what happens is you have discharge units, and then you put all the discharge units into it. And I know if you can remember that I told you about how to calculate with hunters, and also how to calculate with the BS 6700, and we used BS standards to calculate that. And the same way, just like discharge units, what we are going to have here is loading units. So let's just check from the table, like what is the loading unit for shower EWC this. Then I'll tell you there's a very small formula you need to use. So Hmm? So we'll take it as 2. Now, this is the table that we predominantly use, and this is as per BS 120562-2000. And here, if you take the first point where you have the wash basin and that is 0.3, which is called the discharge unit. So we'll take it as DU, and this is 0.3. And the western toilet, if you come here, it is a wash basin with 6 liters, it will be 2. So we'll take this as 2. Wash basin, again you have as 0.3. And the shower is 0.5. So this is 0.5. I took the wash basin one. So this is 0.5. Kitchen sink is again 0.5. And tap point we can take the same as shower. So it is like a wash basin. So it's 0.3. Correct? So if I multiply all this, I'm going to get 30 into 0.5 is 15. And 30 into 2 is 60. 30 into 0.3, 0.9. Yeah. So 9. 2 into 0.5 is 1. 30 into 0.3 is again 9. So I am going to arrive at 94. Sigma du, which is 10, 70, 85, 94. So I have sigma du as 94. But this I need to convert into a unit where I can know what it is, and the very simple formula is in LPS. If I take total volume is nothing but equal to K into root of sigma du. So the K factor here is in the next table. So the K factor is in the table which we need to see. Here we have hotel and it is 0.7. So what I'm going to do is 0.7 into root of 94. So that's equal to, can you find it out? 6.78 LPS. So now you can see how easy it is to calculate how much of wastewater I am going to generate from a 30-room hotel. You can apply this same principle if you have a huge township, or if you're having a hotel with a lot many rooms. Like if you take the star hotels, it's about 100 rooms you might have. You can apply the same thing for resorts. But in the resort, you need to be a little careful about dimensioning all this. Probably in one of my lectures, I will be taking resort as an example and application, and we'll calculate the water demand and wastewater demand for that separately, because it has a lot of demanding varying factors. But here, you can take this as a 30-room hotel, or you can take this as a flat which has so many washrooms, and you just put all that calculated and you arrive at 6.78, which is your peak demand for wastewater. In the sense, when the hotel is in operation and the peak demand in the hotel for water is between morning 7 to 9, you get the same kind of peak demand in the wastewater generated. So that's about 6.78 liters per second. And now I have got the flow rate. With the flow rate, I can design a pumping station, or no? What other information do I need? We will see that later, but now I have this 6.78. I also need to calculate the head, because only after getting my flow and my total head will I be able to select a pump. And the selection of the pump becomes very, very important when you have to design a sewage pumping station. So in this example, what I'm going to have is I'm going to calculate the head. As you said, as you imagine here, I have a pit here, and I'm going to put a few pumps, and from this pumps I'm going to pump it. And I have the sewer line here, and I'm going to put it into the sewer. This is going to be my system. I'm not taking the STP and other things into consideration. I'm just taking a simple example just to show you how to calculate everything, and once there is an STP, that's going to be a different calculation. So what I'm taking is, I have approximately some depth. Let me handle for calculation sake. This is about 5 meter, and the horizontal distance 80 meters, 200 meters you are going to go. Okay, so 200 meters, and probably somewhere I might also have a little elevation. Let's say it is like this, and this is about 5 meters. So maybe, or we are just going this 9 meters. So it's all an example that we are taking. In the sense, I just wanted to give a more of things so that you know how to calculate it. In water, we did a friction loss calculation, and that was using Hazen-Williams formula. And the similar way, we are going to calculate like what is going to be my friction loss, and what is that, and I'm going to have 6.78 liters per second of flow. So what we are going to do now is to we have this, and we'll just convert it into meter cube per hour so that it's easy for us. So this is how much meter cube per hour I get. 6.78 liters per second. 24.408. So 24 meter cube per hour, and this is going to be my peak demand. So I'm going to substitute this into the friction table, and let's see how much the head is going to be. So what I'm doing here is 24, and I'm using a 3-inch, which is the velocity is going up to 1.51, which is quite high. So what I'll be doing is, let me just try to change it to 4 inches. Yeah, I'm getting a velocity of 0.85. That's okay, and I've taken the flow as turbulent, and here I have 200 meters. So my friction loss in the pipe is 1.91. Now I have control valves 3, for example, because I think what I'll be doing is having 2 pumps working and 1 standby, so that it becomes easier for me to explain the factors. So all that I put in, I get 43, 2.34, and I have a static head of 10, which is not the case because this is 5 plus this is 9, which is 14 meters. So I have a head of 14 meters, and I need the minimum pressure at the discharge point to be 5. So what I am arriving at is about 22 meters head. So we need to select a pump which will have this 24 and at the rate of say 22 meters head. So I have arrived at what is going to be my flow and what is going to be my head. But why did I do this first? See, there are so many aspects to designing a sewage pumping station. And one of the aspects to get it into the right place is to select this pump. And I'll tell you again, this might not be the right selection. Because if you select the pump and put it, and this dimension changes a little bit, your static head and your geodetic head will change, so that you will be close and the changes will not be major. So we have to select a pump for 24 at 22. But why am I selecting that pump? The pump has a volute, and the diameter of the volute plays a very, very major role when you want to design a pumping station. It is one of the major roles. So I need to have that first, and after that there are so many other things like effective volume, and what is the volume I'm going to pump, what is my dead zone, dead volume, how I'm going to reduce. And the most important of all that, again, when you come to sewage, you need to have a very good idea about how many starts and stops can your sewage pump handle per hour. Just go through the manufacturer's catalog and find that out, because that is again going to play a very major role when you're going to design a pumping station. Why we are taking so much of effort in designing this pumping station? It's a very small 24, and I'm going to pump two pumps working, one standby, which is 12 meter cube per hour at the head of about 22 meters. And why I need to take so much care about it? If you don't take care of your sewage pumping station properly, you have all the problems, and sewage stinks. So better take care of your sewage pumping station design. There are very small pumps. I don't know how much kilowatt this pump is going to be, but I'll bring that about that in my next episode. The first one I wanted to tell you is how to calculate your wastewater generated from this 30-room hotel, and put all that in the table, come to this formula and I'll correct it, and then arrive at your peak wastewater that can be generated from this hotel. And this we are putting it into the station, and now we calculated how far I am going to push it, and I calculated the friction losses. We took the bends and other things into place, and we arrived at the Q and H. And now there are so many questions in you now, like why this volute diameter is important. What is the distance between the two pumps that I need to maintain? What will happen if I do not maintain the center to center distance? And many places, I don't want to name a lot of things, but they have not taken proper care of that installation. I have seen in places where the pumps are put on freestanding, and they are not standing, they are sleeping. Simple thing is that they have not calculated what will be the turbulence effect in this place, and they have put it close to the wall, and the pump is damaged. So in a sewage pumping, you need to be very, very careful about where I'm going to place it, how I'm going to place it. And in one of the industries, I can tell you, they have put the pump above. And the explanation what the people they gave me is, below there will be silt, so we wanted to protect the pump from the silt, so we took it up. And that's the worst thing that you can do. Your pump is there in this pumping station to pump out all that silt, and you don't want dead zones in your pumping station at all. So that is how you need to design a pumping station. So next thing we will talk about how much from the floor I need to place my sewage pump, and why I need to place there. And the foremost question everywhere people ask me is, can I put a sewage pump using VFD and save energy? So there are so many questions that need to be answered, and I'm sure you will want to know the answers for all that. If you do, please subscribe to pumpexpert.com and wait for our next lecture, where we will be covering a lot. As I told you earlier, this is going to be a very interesting subject, and only if you follow from the beginning, you will be able to understand the entire thing. But if you want to know more and more about this, you are welcome to come and join our course and know a lot more about it and do some practical exercises, so that you can work on a live project and you can see for yourself how you can design a pumping station and all that. This is just nothing but a very small pumping station where we want to give you an idea about it. And if you have any questions, please put it in the comment section, or you have my mail ID at the end of the presentation, and you can always mail me and I'll be happy to answer you. So see you in the next lecture. Until then, have a safe day. Thank you.